All right, here is the 510 homework assignment. We're dealing with improper integrals in this homework assignment. Just 6 questions on this homework assignment. I felt like that was sufficient. I feel like with improper integrals, the questions aren't all that different. I mean, there's a couple different types of improper integrals, and you learn how to deal with each type. And doing so essentially just comes down to rewriting the integral a little bit and evaluating the limit of that integral. Which I don't feel like is all that interesting and definitely doesn't require the repetition that, say, U substitution does, where you need to recognize what U should be equal to and you need lots of practice seeing it in these different tricky situations. At any rate, this first question, I do have a comment on this first question. Actually, I guess I got a comment on all these questions. You're supposed to figure out if they're divergent or convergent. So essentially you evaluate the integral, and if you get an answer, then it's convergent, and that's your answer. And if you can't get an answer, if you get infinity or something like that, then it's divergent. And for this one, if you get your answer is divergent, you put in DNE. Same thing on question 2 and question 3. But for one of these, question 5, if it's divergent, you don't put in DNE, you put in -1 as your answer. So just something to watch out for. Make sure you read through the instructions. And if you get divergent, make sure you put in the way they want you to signify that it's divergent in the first place. At any rate, for this first problem, this one's a little bit tricky because this looks like one of the examples that I did of the type where you have to break your integral up into 2 different integrals. This one does have a vertical asymptote. This function does. It has a vertical asymptote at x equals -5. Because if x is -5, this is 0. 0 to 3/2 is 0, and you divide by 0. But that's not at all relevant for this question because this integral only goes from 2 to infinity. So because that vertical asymptote at -5 does not fall within that interval, then you don't have to worry about that vertical asymptote for the sake of evaluating this integral. So for this integral, what makes it improper is the infinity that you see up here, not the vertical asymptote at -5. So something to watch out for. This one, I don't have as much to say. You look at this, you see an infinity. You change this into the limit of some other definite integral, evaluate the definite integral, evaluate the limit, get your answer, put it here. Nothing too exciting going on in question 2. Question 3 is kind of like what I was referring to in question 1 with the vertical asymptotes, except in question 3 it actually comes into play. So look at this function, determine if and where there's a vertical asymptote, and I think you'll find that it falls somewhere in this interval. And so maybe you need to rewrite this integral as the sum of 2 different integrals. And maybe each of those integrals you can evaluate with a limit. Question 4, the trick here is that the natural log of 0 is undefined. So I think you're probably aware of that at this point in the class, but just in case you're not, be careful. Make sure that you recognize that the natural log of 0 is undefined, and therefore you're going to have to change one of your bounds of integration into a constant and evaluate a limit. This one, again, you see natural log, and you're like, oh yeah, natural log of 0 is undefined. Well, that's true, but because my bounds of integration go from 6 to infinity in this problem, the fact that the natural log of 0 is undefined is completely irrelevant. It's the infinity that makes this problem weird, not a natural log of 0 issue with question 5. And then question 6, the extra credit one, although I don't really know why it's the extra credit one. I don't think there's anything especially tricky here. You got this infinity up here, so you're going to have to evaluate a limit. I guess taking the antiderivative of this thing is a little bit tricky. You might have to think integration by parts, but I think this is all within your grasp. I think you can do this. This one, for kind of a shorter homework assignment, as far as the number of problems that you have, it might make sense to knock this extra credit one out, get 120% on this one, in case you've lost any credit on any other homework assignments. But I don't have a whole lot as far as hints go. So that's all that I have for this video.